Hello everyone. Uh, in this we will see our next problem, which is valid palindrome 2. So this is different from just finding out the palindrome. So the difference is we'll see the what is difference. So given a string yes, return true if yes can be palindrome after deleting at most one character from it. So which means yeah, so we'll see the examples. So this is palindrome, since so palindrome is a string with nothing but which reads same from left to right and right to left. So here you can see a b it, which is a string palindrome, and here a b c e c a is also a palindrome because it is given that uh, uh, it should be a valid palindrome even after deleting you can have a chance to delete at most one character. So here we have a not deleted any character, but here we can delete c and this will become palindrome. In example 3 we can see we even if we delete b, it becomes c ac, and which will not become palindrome. And even if we delete c, it will become ab, which is also not a palindrome. If we have a chance to delete two characters, which is if we delete any two characters bc or any two characters, the string will become palindrome. So this is our question, so we will see the solution. So we will take one example and see the solution. So we'll take this example. So here we got this string, and we got this string here, and we are here creating a new method called validate palindrome helper, where we are passing the given string and index 0 and the index of last character, which is len len length of the string minus 1, and the one, this one is the at most how many number of like at most one character. Here we are given a chance, so that number include that. So even if in question they were given two characters at most, we can delete and make it a palindrome, then we can pass it as 2 here. Or like if we are given a three chances, then we can pass it as a 3. So we get those values to this method, and until uh, like string is matching from left to right and right to left, we do same as a normal palindrome, where we check uh, we pass one pointer to we to take two pointers for one pointer will start from beginning and one pointers from end, which we have passed here, index 0 and in last index. And we will keep incrementing this pointer, and we keep decrementing this pointer until the condition becomes false, which is we are running a while loop where I is less than j. So this is I, so this is j. Initially this is I and this is j, and until I less than or equal to j, this while loop runs. So here we check yes, s of I double equal to s of j, which is in this case e is equal to e. So it will go inside if condition. I becomes plus plus, I will come here and j will come here. So let me just annotate here so that it will be easy. So this is I and this is j initially. So j will come back, j becomes minus minus, so j come back, and I becomes plus plus, so I come to here. And bb will be compared, bb is equal, so again this will go inside this if condition. And I comes here and j comes here, and they will be again compared, cc equal, and j comes here, I plus come, I moves forward and j moves backward. And bb is same, so I moves forward and j moves forward backward. And again now bb is same, so I move forward, which I know points to E, and J points to C. So here is the here this condition becomes false, so it will go inside else condition. Since we have a one extra chance where we can ignore one character, so we are like we are subtract we initially we had f equal to 1, so mm, we are subtracting 1, which is f minus minus, and then we are now dividing it into two, like recursively. So for first here we for ignore E, and we start from C, and we include all this substring from this to this point to this point. So here we started from C, and again we have kept C, and we continue the same thing, like compare C with C, and increment I, and in decrement J, until we reach until this condition becomes false. So here what one more recursive what we'll do is we have here we have ignored the first I character, but here we are ignoring jth character. So here we include e to e e to this substring. So we include this substring. So e to e, and we ignore this c. So here is the case, like if you have written instead of recursion, if you have written a if condition, something like first initially if you have written a ignore e and compare c c, then it becomes true, and again e e true, c c true, and it will become true until this condition becomes true, and you will return a true. But if you have written this condition first, which is ignore jth value first, for example c, you have ignored c, then you will be comparing e and e, so this has become true, and here is the trap, this is the trap. So again c became true, but e e and c is not, e and c are not equal, and you will think that will go inside this else condition, not this else if condition, because f already became 0. So we are returning false, we are assuming the string is not palindrome. So that is the reason we are here recursively calling two, we are validating two strings, not one string. So here in first string we are ignoring ith character, and here we ignoring jth character, and we are comparing. So here, as you can see, this is valid palindrome, because c c equal e e equal, and c c equal a b b equal, and condition becomes false where I not less than, not I greater than become equal to j. At this position I comes here, and j comes here, so this condition becomes false, and we will be returning true. uh, and here we get true, and this will become, here e will be compared, c will be compared, a e will be compared, and this is false, a is not equal. So this will return false, and we get false here. So true or false is true, so we will be returning true. So that's how we are getting our answer. So this is the only the difficult part in this program is to uh, initially we think writing a if condition is enough, but writing if else condition will fail this condition, fail uh, this condition. So we should consider we should try we should compare we should try out if the string given strings are palindrome or not, to both strings, not one. So if you compare for one string, then we'll get false. So this is our solution, and here we are our time complexity is order of n, where n is the length of the given string. You may be thinking we are recursion and our time complexity will be more, but but here we are using recursion only once. So even in worst case, like if if the string was mismatched initially itself, we will be we'll be comparing checking the string is palindrome or not two times of the given string length. So it will become 2n. So the dominant term is n, so that is the reason term complexity is n. And the space complexity is order of 1, because even here also you can think of think we are using recursion, so it will be order of n. It's not, because here we are calling only once the recursion, so that is the reason time complexity is space complexity is order of 1. Because here we are using just constant spaces. All these are constant spaces, and is this recursion also just a constant space, just two recursion. So that is the reason the space complexity is order of 1. So this is our solution. I'll share the link of the solution and this image in the description of this video, and thank you for watching.